Hello everyone, my name is Ahmad and I'm an AppleSmart teacher. At AppleSmart Teacher Academy, I currently teach Introduction to Geometry and a summer pre-calculus course. I'm also planning to teach Introduction to Algebra soon. I'm a senior mathematics teacher and a sessional instructor at Simon Fraser University in BC. I hold a PhD in mathematics, and I have more than 20 years of teaching experience at both the high school and university levels. Over the years, I have taught many different mathematics courses, both in private and group setting, and both online and in-person formats. I have worked with students from grades 6 to 12, as well as university students. I have experience teaching based on the Saskatchewan and British Columbia curricula, and I'm also very comfortable teaching from AOPS textbook, including courses such as Introduction to Geometry, Introduction to Algebra, and Pre-Calculus. My teaching approach is simple and student-centered. First, I try to introduce the basic ideas in clear and simple language. Then, when we move to more advanced concepts, I use several examples to help a student understand how the ideas work in practice. For more challenging problems, I usually break the problem into a smaller and more manageable parts. Once the students understand each part, we put the pieces together to build a complete solution to the problem. In my classes, I like to show all steps clearly. For in-person class, I usually use a marker and board to explain the solution step by step. For online classes, I often use screenshots of the problems and write directly on them. This helps students first understand the question clearly and then see how we can solve the problem using the new concept we have learned together with their previous knowledge. I believe students learn mathematics best when they feel comfortable asking questions, making mistakes, and thinking step by step. My goal is not only to help students solve problems, but also to help them build confidence, improve their mathematical thinking, and enjoy the process of learning. Now, let me briefly show what I mean by using screenshots during my online classes. I will take a sample problem, means after introducing the notion, I will take a sample problem and explain how I guide the students through the question step by step. So let me just share my laptop screen. Here we are. So this one is pre-calculus course. The textbook is pre-calculus. And then I want to just briefly introduce the notion of function and in-depth function basics. This one is exactly is online course I currently have in AppleSmart Academy. You can see, let me just at first introduce the basic notion here. So let me just take a screenshot. As I said before, I normally use this method. You can see. Suppose I want to talk about the function. So let me just show you what I mean here of a screenshot. So then I can take a screenshot of this one. Suppose here, suppose this one. And then we can start on the function basics here. As you can see here, a function can be seen as a machine that accepts any number, and then we will have exactly a unique output from that machine. If you are talking about a function, that output must be unique. Let me just show you what I mean here. Suppose this one is that machine, okay? Then we have exactly one input suppose here and one output suppose here. For example, this one can be that machine. What is the task of this machine? If the output is this one here, the machine task is take input, multiplies that input by 2, and then add 3. The result will be 2 multiplied by input plus 3. This is just one example of this machine. Again, this machine in general is not a function. This machine is a function. So we can write down here, this machine is a function if y, or I mean is here output, is unique. So if you have a machine, takes one input or multiple inputs, no matter, but if the output of that machine is unique or single, then the machine is a function in mathematics. For example, here, if you consider for this example, if f is name of this machine, and suppose the input is x, then output can be 2x plus 3. You can see, for any input x, we have only one output, 2x plus 3, not two or more outputs. So for sure, this machine f is a function. But if you have a machine, suppose g, and suppose we have for one input x, we have two outputs, suppose y and z, so this machine is not a function in mathematics, because we expect if the g is a function, we must have just one unique output from there. But now you can see we have two outputs, y and z here. So g is not a function, but f is a function. Now we want to just look at different concepts or basic concepts related to a function. The first one I want to mention here is domain and range of a function. So let me just take another screenshot of here, and then we can see what is the domain and range of a function here. Okay. So let me just consider just here. I want to just focus on domain of a function. Domain of a function. Again, look at a function. We said a function can be seen as a machine. So input can be different, can be multiple inputs we can have, maybe x, y, z, no matter. Suppose here we can just simply we can consider just one input here. And of course, output must be unique. So here is exactly a machine. So what is the domain of a function? The set of possible values for x or input is called domain. So the set of all possible values of x or input is called domain. So domain of function means what is the set of all possible values for input or x. I will give you a very nice example. So before that, I want to show you here what is the range of a function. So very similar to this one, just for range, you can see range of a function simply can define like the set of all possible values of y or output in a function. So then let me just exactly write down here what is the definition of the range of a function. The set of all possible values of y or output is called range of the function. Okay, so now I want to give you an example here, a clear example of what is the domain and range for a function. For example, if the function, do you remember the previous example, 2x plus 3? So suppose here the machine is here exactly is 2x plus 3. I mean, is suppose this one is the machine name is f. We saw that already. If input is x and output is 2x plus 3, this one exactly is a function in mathematics. So now we are interested to see what is the domain and the range of this function f here. So in your idea, is there any restriction for values of x? Mean x can x be a positive number? The answer is yes. X can be 2, 3, 1 over 3, square root of 2, any positive number. X can be 0. Yes, X can be 0. Can X be a negative number? Again, the answer is yes, because suppose X is negative 2, so just X replaced by negative 2 is 2 multiplied by negative 2 plus 3. Of course, it's okay. And so X can be any negative number, any positive number, and 0. This means domain of f of X is any real numbers. Don't forget the numbers learned so far, suppose are just real numbers. Of course, we have complex number, but this is not the topic of this discourse here. So we always consider just real numbers here. Domain of this function is all real numbers. Any number you already learned is called real numbers set. So x is an element of that set. So what is the range of this function? Range of function f of x. Again, all the set of all possible values for y or output. So now look at output here. The output is 2x plus 3. So my question here is, this output can be positive? Of course, yes. 2x plus 3, of course, can be positive, right? Because if you consider, suppose, the possible value for x, suppose positive numbers, and any number greater than minus 3 over 2, because if you put minus 3 over 2, that 2x plus 3 will be 0. But any number greater than that one, of course, make 2x plus 3 positive. So then 2x plus 3 can be positive. Of course, can be 0 because, as we mentioned right now, if you replace x by minus 3 over 2, the answer will be 0. So 2x plus 3 can be 0 and also can be negative because any number less than this number make 2x plus 3 negative. So it seems that the output can have any values from positive to negative or from negative to positive. So this means, again, any real numbers. Okay, any real number can be range of this function. So now we're going to just show domain and range in different notation. We can say interval notation. What is that one? So let me just take another screenshot of here, and then I can show you what I mean of that one. You can see here. So now we want to talk about interval notation of a function. Of a function. I want to start with very simple word here. Suppose we are talking in some problem. The answer is supposed to like this number. Any real numbers. How we can show this one by interval notation? Any real numbers means a real number set. So this set is exactly can be denoted by this notation R with one line, small line near to R here. And then we can call mask R, or in notation for in interval form notation is minus infinity and infinity. This is just notation for any real number. Okay, so if the solution is any real number, any real numbers, suppose less than 5. So how we can show this one using interval notation? So you can see any real number less than 5. This means x is x from negative infinity to 5, right? So less than 5 is not equal to 5. So then the notation is minus infinity and 5, but parentheses here. Parentheses means excluding 5 because we say the less than 5. So this one is interval notation for any real number less than 5. So now, what about any real number, suppose greater than or equal to 2? What is this one? How we can show this one by interval notation? So now you can see any real number greater than 2 or equal to 2. So this means it starts from 2 and including 2. So this one by a square bracket will be started to infinity. So infinity or positive infinity. No matter this is just infinity or positive infinity, they are same. So this is exactly is interval notation for this statement. Any real number greater than or equal to 2. So now what happens if we want to show the numbers in a number line between two different numbers, between two constants? Suppose any real number between 2 and 5. So in your idea, how we can show this one? So to clarify more about this statement, maybe you will ask, what about 2 and 5? They will be included in that interval or they will be excluding. So normally they mention exactly, suppose including 2 and 5, means both 2 and 5. So then this means 2 and 5 with square brackets on endpoints. So what about this one? Any real numbers between 2 and 5, but excluding 2 and 5. So of course, we can use just parentheses to show this interval or this set of numbers. What about if we have just including one number and excluding another number? For example, what happens here, if we consider any real numbers between 2 and 5, excluding 2, but suppose excluding 5. So this one will be exactly 2 including and 5 excluding, will be like this one. I believe that you got the things right, but don't forget always when we have negative infinity or infinity, so since they are not exactly constant number, always we use parentheses notation for these two concepts, because this one actually is a conceptual number. We don't have exactly constant number with equal to minus infinity or infinity. Okay. So this one is definition of domain and range. So now let me just show you, at least we want to solve one problem related to these things just now we learn. So I think you can see this problem here. Problem number 1, I want to show you. We have a set of problems here, problems 1 to 1 to 1 to 7. And normally in our class, we try to solve all questions one by one. Depends to our time. If suppose we are in our course is summer course, so maybe our time is a bit restricted, so we cannot maybe solve all questions. But in normal semester, in a normal semester, we can solve almost all questions in any section. So focus on problem 1.1. I want to show you how normally we solve a question here. So again, we can take a screenshot of this problem. Let me just do here. This one is exactly the question with 3 parts, A, B, and C, as you can see here. So let f of x is 2x squared minus 3. Find f of 2. What does it mean, f of 2? Don't forget, any function can be seen as a machine, take one input and gives an output. Okay, so here f of x is exactly that machine. The input is a seeded x and the output is 2x squared minus 3. This means if can take the input x, make a square that one, multiplies by 2, and then minus 3 will be exactly the output of that function. So now we expect to, for f of x, we have this this is the output, 2x squared minus 3. So what about f of 2 for part A? F of 2. So of course, input now is just number 2. So again, that number should be squared multiplied by 2 minus 3. This means 2 multiplied by 4 minus 3 means 8 minus 3, which is 5. So 5 is the answer for part A. This means function on input 2, or f of 2 for short, f of x, f of 2. So part B question. Find all values of t such that f of t is exactly 47. So we want to find all values of t such that we have this identity. So in your idea, what is f of t here? Of course, the input can be different notations, right? Can be different variables. Normally, input variables is called in this chapter at least dummy variable. But in different textbook, maybe you can see like independent variable for inputs variable. Okay. And if the output of a function is always real number, which is we assume always in this chapter, the function is called a real function or real valued function. They are saying a real function means the output of the function is real. Anyway, we want to focus again on that part B of this question. F of t, f of x is this one. So what we expect of f of t, just x, just input will be changed to t, right? So we expect f of t to be equal to 2 multiplied by t squared minus 3. But f of t suppose is exactly 47. This one exactly is 47. So now we want to see what is the possible values for t. So then just focus on this identity. To solve this identity, we can maybe add 3 to both sides. This one can be cancelled. So 2t squared is 47 plus 3, which is 50. So to isolate t on the left side, we can divide both sides by 2 here. So then 2 and 2 can be cancelled. T squared is 50 divided by 2, which is 25. And I agree. If you agree, the answer here is t can be two possible value, 5 and negative 5, positive and negative 5. Do you agree? Maybe we can check our solution by plugging these values into the function. The function is exactly here. We want to see really, okay, we want to check this identity here. Let me just show you exactly. We want to check this identity here. So now just take t equal to 5 at first and check f of t exactly is 47. This is just verifying our answer, right? If t is 5, you can see f of 5 is 2 multiplied by 5 squared minus 3. 2 multiplied by 5 squared is 25 minus 3. 2 multiplied by 25 is 50 minus 3, which is 47. So this one is verified for t equal to 5. For t equals negative 5, then you can see f of negative 5, again, is 2 multiplied by input, which is 1 negative 5 squared minus 3. So 2 multiplied by negative 5 squared is negative 5 multiplied by itself. Of course, it's 25, but positive. Minus 3. So 2 multiplied by 25 is 50 minus 3, which is again 47. So again, we confirm this identity for t equal to negative 5. And last question is part C. Find function on input 3x plus 1. We know that if the input is just x, the output is this one. So now we want to see what about this one. If the function is same, but input is 3 multiplied by x plus 1. So then this one is 2 multiplied by the input squared. So input here is 3x plus 1 squared minus 3. Even you can simplify this one because we already learned a plus b squared on the top left side. I'm just writing what is the a plus b squared. This is actually our previous knowledge. If you don't know, just simplify. Simply you can just consider multiplication between a plus b and itself. But if you solve this one, we can arrive at this very famous identity: a squared plus 2 multiplied by a multiplied by b plus b squared. So now using this one, we can just simplify the expression for that square of binomial. So it will be 9x squared plus 6x plus 1 minus 3. If you simplify this one, is 18x squared plus 12x plus 2 minus 3. But this one, of course, is negative 1. So 18x squared plus 12x minus 1. So this one is final answer for part C. Find f of 3x plus 1. So we could solve all parts of this question, which was problem 1.1. Thank you for your attention.